Let's consider the equation 4 raised to the x equals 32. To solve an equation, we want to isolate the variable. And in this form, it's difficult to isolate the x. So what we're going to do is we're going to try to change it to logarithmic form by taking the logarithm of both sides. If we do that, we would have the logarithm of 4 raised to the x equals the logarithm of 32. Now, if we take that exponent, and as we've learned from the power property, we move the exponent to the front, we would have x times the logarithm of 4 is equal to the logarithm of 32. Now remember, logarithm of 4 is a number. Here we essentially have an equation that reads x times a number is equal to a number. So to get x by itself, we need to get rid of that number that's multiplied by x. We would divide both sides by that number. Here we divide both sides by the logarithm of 4. And the result would be x equals the logarithm of 32 divided by the logarithm of 4. Now, if we use our calculator to calculate this answer, the logarithm of 32 divided by the logarithm of 4, the result is 2.5. And that's our answer. So when we have an exponential equation with a variable in the exponent, to solve it, we first will need to get the exponential expression by itself. Isolate it so that you have a base raised to an exponent equals an expression. Then we'll take the logarithm of both sides, use the power property to bring the exponent to the front, and then solve for the variable. Let's examine the equation 3 raised to the x minus 5 equals 10. Here we have an exponential equation with the exponential expression by itself. We're going to take the logarithm of both sides. And next we use our power property to move the exponent to the front. Here we have x minus 5 times the logarithm of 3 equals the logarithm of 10. There's a few different ways you could proceed from here. What I often find helpful to go ahead and do next is divide both sides by the logarithm on the left. This would give us the equation x minus 5 equals the logarithm of 10 divided by the logarithm of 3. And now, to finish and get x by itself, we add 5 to both sides. And we would have x is equal to the logarithm of 10 divided by the logarithm of 3 plus 5. And if you would like to, you can use a calculator to get a decimal answer. There's not a whole lot we can do to simplify it exactly, except the logarithm of 10, when it's not showing a base, you assume that the base is 10, and the logarithm base 10 of 10 would be 1. So we could write this in exact form as 1 over logarithm of 3 plus 5. Or if we do calculate this as a decimal answer, which would not be exact, but it can still be helpful sometimes, 1 divided by logarithm of 3 plus 5, we would have as an answer approximately 7.096, rounded to 3 decimal places. Let's take a look at one more. Here we have 6 times 2 to the x equals 50. An important first step before we think about logarithms is to get the exponential expression by itself. Here, the only thing that is raised to the x is the 2. So to get 2 to the x by itself, the first step here is to divide both sides by 6. And this leaves us with 2 raised to the x equals, and I'm going to leave a little bit of space because I know I'm going to do something to both sides in just a second, equals 50 over 6. And now I can take a logarithm of both sides. On the left side, I can move the exponent to the front, and we would have x times the logarithm of 2 equals the logarithm of 50 over 6. And to finish, we would divide both sides by logarithm of 2 to get x by itself. And this would give us an exact answer of x equals the logarithm of 50 over 6 divided by the logarithm of 2. That would be our exact answer. And if we would like to type it into the calculator to get a decimal solution, logarithm of 50 divided by 6 divided by logarithm of 2, our result would be about 3.059, just choosing to round to 3 decimal places. Let's take a look at another one. Here we have 3 times 4 to the x minus 5 equals 43. First, we need to get the exponential expression by itself. In this case, to do that, we begin by adding 5 to both sides. And that leaves us with 3 times 4 to the x equals 48. Next, we divide both sides by 3, leaving us with 4 raised to the x equals 16. Then we take a logarithm of both sides. The logarithm of 4 to the x equals the logarithm of 16. We move the exponent to the front, giving us x times the logarithm of 4 equals the logarithm of 16. And then to finish, we divide both sides by the logarithm of 4, and we have x equals the logarithm of 16 divided by the logarithm of 4. And if you enter this into your calculator, you'll find the answer is 2. Sometimes, in certain lucky situations, you'll get to a point at an equation right here where you can think about it and figure out the answer. Here we're thinking 4 to what power is 16? And we know that 4 times 4 squared is 16. So sometimes if you're lucky, you might be at that point and be able to figure out the answer in your head. If not, take the logarithm of both sides, pull the exponent to the front, and divide to get the exponent by itself. If you would like to solve the next problem on your own, pause the video now and resume when you're ready to see the solution. Here, to isolate the exponential expression, first, we would subtract 6 from both sides of the equation. This leaves us with 7 times 5 raised to the x is equal to 94. Next, we would divide by 7 on both sides, and we would have 5 raised to the x equals, I'll leave a little bit of space at the front, 94 over 7. Then we take a logarithm of both sides. we would pull the exponent out to the front on the left side, leaving us with x times the logarithm of 5 is equal to the logarithm of 94 over 7. And last, to get the x by itself, we divide both sides by the logarithm of 5, leaving us with x is equal to the logarithm of 94 over 7 divided by the logarithm of 5. And if we enter this in the calculator to get a decimal approximation, we would have about 1.614, rounding the answer to 3 decimal places.